I'll start out. Is anybody here in the dairy industry? Okay, we got one guy here, so that's good. So I love talking about engineering, Solidworks, simulation, everything. And I love talking about anything farming or agriculture. So in this talk, I'm sort of putting the two together. So I can get pretty excited about it. But we'll try to make it interesting and relevant for everybody here. I guess might as well get started. All right, just a bit of an overview. So what we're going to talk about today is a mod sim example. So modeling and simulation all sort of put together in the same time. And I walk through this example, and the simulations really aren't that complex or sophisticated, but I feel like it's a really good example of the process. And that's kind of my greater goal, is to really talk about the process that I'm using here at Seneca. And the goal is to maybe to give everybody some insights or some maybe helpful observations of how you can take some of these lessons that I've learned and use it to help your process, change your process. So I got one person here that's here for the cows, and everybody else, they can, hopefully I'll be able to help you guys too. And I try to make it about the process and less about like the exact tools that I'm using. There's a broad range of tools that are available, and hopefully you can take some of the insights about the process and apply them to whatever tools you're using on the simulation side. So. Okay, just quick background about me. I work for Seneca Dairy Systems. We're located in Seneca Falls, New York, and it's in upstate New York, it's sort of a rural area there. And we design and manufacture equipment for dairy facilities. And that is just a good fit for me for the job. I love everything about agriculture and engineering, and to just really get a chance to put those two things together in my position there as a mechanical engineer. And so just a little bit about Seneca, so you sort of understand my perspective. We're sort of have four verticals, and the first one is the dairy facilities. So we're basically designing, manufacturing equipment for those dairy facilities. And the second one is the installation. So we've discovered as part of the business model is it's important to have your equipment installed. So we have contractors and partners and people that we work with to help get that equipment installed. We also discovered that the same factory that builds dairy equipment is also really good for building industrial attachments. So we also sort of have another vertical there where we sell just attachments, steel stuff, cut, bend, weld, and it fits our production very well. And then the fourth one is custom builds. There's a great demand for sort of custom solutions, custom engineered solutions. And we have an entire sort of department that just focuses on filling that need. So that sort of helps you understand where we're coming from, where we're at it as a company, and where I'm coming from as an engineer. That's what I deal with every day. So just real quick here, I wanted to throw this slide in, and it says our journey. And Seneca as a company has really changed and grown over the years. And when we were starting out, all of our products, were really very simple, straightforward products. Didn't really need CAD or drawings or 3D anything. And as the business developed, the owner really had a vision to make more complicated things to sell. And Solidworks was sort of a key part of that, and you can see the progression of our products becoming more complicated, more complex, and more sophisticated. And in 2021, when we moved to the 3D Experience platform and using that for our simulation, it's sort of another step. And that's part of the mod sim journey is we weren't always there. And that it's been a process of change and growth. And we're excited about where it's taken us, and we're excited about where we can go with it too. So, okay, so now we get to talk about the milking parlor. So that's going to be our sort of design challenge today. And so first you have to sort of explain, I have to explain a little bit about what a milking parlor is. So the top view in the image there in the bottom right of the screen there, that sort of shows how the cows move. The red arrows is where they would enter the parlor, and then they get milked, and then they exit the parlor in the green arrows, and then they turn and they go back. So I have some videos that sort of explain it pretty well. So this is the first step here. The gate opens and all the cows file in. Okay, and they learn that they come in and then they turn sideways and they line up. And there's workers standing in the pit behind them that milk the cows. So, you know, well-designed parlor, they all come in and they'll just line right up. And so that's them there. So then during the milking, the important aspect of it is that they just be very comfortable. So when the cows are comfortable, you know, their production increases, and you know, so you want them to be very comfortable. That's just a great advertisement of how comfortable they are, just standing there relaxed, being milked. And then the lift and the exit. So what happens is the whole front lifts up at the same time, and then the cows step forward. And it's very natural for the cows when they have this weight on their shoulders, sort of when they're standing there being milked. And when the fronts lift up, you know, just like if somebody's you know leaning against you and they step away, you sort of have an urge to, like, you know, fill that void. So when the fronts lift up, the cows naturally take a step. Well, the other little trick is the floor is sloped, and then you have like a 4-inch step on the concrete. So when the cows take a step, then they're taking a step down, and then they take another step, and they take 3 steps, and they're out of the parlor. So as you can see in that video, the fronts lift up, and then they all step out at once. So it becomes a very efficient way to unload your parlor very quickly, and then the cycle starts again. So it just becomes an efficient cycle to load and unload your cows in your milking parlor. Well, that's all good and grand and everything, and there's different ways that people do this. The solution that we're currently using to help lift it evenly is we have a shaft that runs the whole length of the parlor. And there's different things like related to the variances in the pneumatic actuator. A lot of times there can be variations in the air pressure. So to even all of that out and get all of the fronts to lift evenly, we're using this a jack shaft concept. So it's just normalizing all the air pressures and any friction differences. So yeah, that seems all good and grand and everything. And I got a little animation there, so that's what it would be. Everything lifts up, they step out. Okay, well, what happens when the parlor is only partially loaded and all of the friction on one side of pulling up the cows tends to cause all those fronts to lift unevenly? And the shaft is supposed to equalize all of those forces. But the problem is, we've been having quite a few field failures. And this is due to sort of a variety of things. We've got some installation complications because the milking parlors basically have zero downtime. Installation can be complicated, and I think ultimately it shows that our design process didn't work, because when we launched this, we thought we had a good design. We thought that it was going to work, and it kind of does, but kind of doesn't. So we definitely needed to improve it. And how can we improve it? Well, we can introduce the simulation right in front in the design process. So this is sort of a little bit of our initial design process. We used a very siloed approach. So each engineer and each designer would sort of own a project from the cradle to the grave. Years later, if someone has a question about the milking parlor, they'd come to me, or if it's a different product, they'd go to the different person. So everything was sort of very vertical, and we would just use the simple hand calculations, Excel, just things like that. And in this case, I have a little chart here, and all I was able to do was to look at the mass of the parlor fronts lifting up and down. I know that, and then I also know the maximum force of my pneumatic actuator there, based on the pressure and the size of the cylinder. So I try to do some calculations there and see how the shaft is going to twist, and it's pretty one-dimensional. But hey, it's the best I could do. So then we design it in Solidworks. We add a little hope in there, and we build it. So that's sort of my initial design process. So to transition, what we transitioned to was more of a task-based project approach. So now is what we do is we have different projects and we break things out into tasks. And that has just been sort of a powerful transformation in and of itself, and allows us to be more specialized and focus. Each person can sort of do what they're better at and focus on that, and it allows us to work across different projects. And so then we have our SolidWorks data, and I've got my little sun there because all of our data sort of revolves around SolidWorks, and that's our single point of truth there. And so all of our data lives in SolidWorks. We're using the 3D Experience platform then for our different collaboration. So everything starts in SolidWorks, and then the next step would be Xmotion. That's a browser-based motion app. We're using that to study the dynamics of the system. Then we export those loads to Simulia. That's our simulation tool. Then we're running our stress analysis there. Then we look at our results, and then we build it. So, and a lot less hope in there. It's a much more rigorous design process. So whenever I see these presentations, I always wonder, what are those people actually using? So this is, if you want to study it later, you can look. These are the actual tools that I'm using, the different roles that I have and that I'm showing today. So if you're interested later, you can go back and look at the slides and dig into that. So maybe just a little bit more of my OCD there. Okay, so our calculations. So I always get very amused when I see this, just sort of combining my my engineering and my ag hats there, and I always think that's hilarious when I see that. So my calculations. Here's another one I find amusing. Everybody's talking about AI and vision systems and everything. So sometimes it doesn't quite get it right. So that's a funny one too, I thought. Okay. All right. So, all right. Let me get into the motion setup. Okay. So what's the problem? Like, well, what am I trying to discover through my motion study? And what I really want to know or understand are what are the shaft forces. Okay, so my setup starts in Solidworks. That's where it begins, and then I open it in the XMotion app, and this just shows that it's bringing in all of my parts and assemblies and everything from Solidworks right into XMotion. Okay, so I come over here and I set up the mechanism. And this was a bit of a learning curve for me because the way that I thought about it is as a designer. I'm like, okay, I'm already building everything in SolidWorks. It's like, why do I have to change anything? And as I really got the hang of it, I understood that when I build my assemblies in SolidWorks from a designer perspective, I have certain goals in mind. And we generally would build our assembly how we actually manufacture it in real life. That's how we put everything together. But when I'm performing a motion study or a motion setup, generally I have slightly different objectives. And by using these markers and the joints and the loads, I have to think about it that way. I think about it as a mechanism. And that was a bit of a shift for me. But learn to use those tools was a really powerful to be able to set up these motion studies. And in a way, it is actually very similar to when I build my assembly in SolidWorks. I have certain goals in mind. Well, when I set up the motion, I have certain goals in mind as well. So in that way, it is a similar process. Okay, so I start out by looking at what the shaft RPM is. I was not too scientific about it. I literally watched the video and looked at the timestamps, and I have two different RPMs or two different speeds I can see by watching the video. And then you can see here, I started out with just a little Excel table, and then I open it in using the data points. But what I like about these data points is it also shows you a little chart. So right away I can adjust my data points so I can make sure that I'm getting my RPMs where I want them and getting a smooth curve there. Okay, step 2, I'm looking at the torque. So I converted back from the mass and the friction of the cow pulling up, and I convert that into a torque. Now, I didn't know what the friction was on a milking parlor pulling up along the side of a cow, so I guessed. And I just put some numbers in there, but I was able to work at it so the numbers made sense, okay? Based off of what I knew the cylinder was giving me as far as forces. So yeah, I kind of guessed, but I'm pretty confident that my guess has a good range there. So what I really want to show right there is the scale and offset. So there's a little box down there at the bottom that I have highlighted and then blown up a little bit there. And really what I did is I only had one data set, and I was able to build or basically one column of torque, and I built all of my other scenarios off of that one column of data by simply changing the offsets and using the multiplication factors there. And how this is helpful for me is because I know that all of my inputs are basically derivatives of the same values. So I can quickly and easily build all of those different input functions that I need to. And if I want to change it, then I only have to change one thing. I don't have to go back and change each one, because I've already set up my scales and my offsets. I can change just the main function value, and all of my scales and offsets are the same. So that's a really cool feature there that I use quite a bit. Okay, so then this is a little video here. And so the next step of my setup of my mechanism is to duplicate it. So after I had my initial load case set up for the even lift, I wanted to see what the uneven lift would be. So I simply go in and I duplicate it, and then I go back in, and you can see what I'm doing is I'm opening up all of the different torque inputs, and then I delete the function out of it, and then I put the other function in. So within a minute, I'm able to create a whole new scenario of a different loading condition. And I really like that, the power of that, because it's so much simpler to thoroughly build my model out in a way that I would never be able to do if I was just hand calculating it. So you can see I go through and I switch out all of my different functions there on the torques. I save it and I run it, and very quickly I am able to produce a whole new scenario. So we got that. Okay, my results. So there's three things from the motion that I use for results. The first is the animations. And this animation really isn't that compelling. Basically, it's just spinning around. It's nothing too exciting. But I will say that the animations actually have been very useful for me, and I have used them with different customers, and the helpful just giving me that visual feedback. The charts, it's real easy to visualize your data, what's happening with the charts. And these charts here are just automatically generated based on, you just have to select your different inputs and outputs. But you can also export it to Excel, and if you want to work in there, you can do that too. And then the third output that I get is directly exporting my loads to Simulia. Okay, so in reality, that's my ultimate goal. Is I want to know what the loads are, but I also need to know how those loads are affecting my stresses in the device. Okay, so decision points. How does this help me make decisions? Well, first of all, I'm able to dynamically understand and evaluate the system. As opposed to originally, all I can see is a static analysis of what's happening at one point in time. So now I can see what's happening over time and dynamically. I can quickly and easily evaluate different load cases. So not only can I do it once, but then I can easily replicate it. Once I have the setups, I can look at a whole variety of different ways that this is loaded. And then I'm able to directly export those loads to Simulia for my stress analysis. Okay? Okay, so moving on. So what's my next problem? Is the shaft strong enough? So this would be my ultimate question. So I have to know whether this is going to survive. So the first part is just really understanding, developing those forces that's on the shaft. The next part is really digging in, is the shaft going to be strong enough? So first I start sort of the same process. I have to build up my model. I have to look at the different scenarios, and then I have to evaluate my results. Okay, so I import my loads, and I had to do some work to get the loads how I wanted. They don't come in exactly perfectly the way that I wanted. So I do some work with the setups, getting those loads reattached. That, and then meshing. Okay. So let me just go to that. Okay, there's my next slide there. So the next step in my process then would be to build my mesh. So as a designer, I wouldn't be the expert on meshing. But what I like about these tools is it's a really good combination of sort of automatic, but yet you can also work at it manually and customize those. So the more proficient I become with it, I'm also able to go in and use more of the customized tools. And to me, it's a really good balance. And you know, I know that I can use some of the automatic tools. They're there, and they're good, and they're powerful. But yet, as I become more proficient, then it's also a good fit as well. So most of our simulations are relatively simple and straightforward, or at least I try to keep them that way. Okay, so virtual bolts. What I wanted to show here, on the right side is the assistant, and the thing with the assistant that I realized is, as a new user, it really helped me a lot. But as I became more proficient, I still use it. And it's I feel like a good tool that sort of streamlines your workflow even as you get more proficient. It still sort of just helps me focus on just working through the bullet points of what what I need to do. Okay, so inputting my boundary conditions. This one is pretty simple. I'm just using the virtual bolts as my fix, and then I have some loads on there. Okay, I think I gotta. Okay, so this is just showing the cloud solve. At first, I didn't really see much value in the cloud. I was like, well, most of my simulations aren't, taking 2 days to run or whatever. But then one day I was like, in a way, it doesn't matter whether if it's 20 minutes or 2 hours. My time is still valuable. So I find that I end up still using it, and it also helps because I don't have the most powerful computing machine. So I don't really suffer as much by not having a very powerful machine. So what I'm showing here is when I go to do my computation there, my cloud solve, I'm saving my previous results. So as I work through my different design changes and different scenarios, that's how I'm able to compare different parameters, different designs. So here you can see then this is the tool that I would use to study the comparisons. So I just dragging them in there. So ultimately for me, there's a lot of my simulations are really coming down to comparisons. Okay, is this design better than that design? So this tool is very helpful for me. Okay, I think so. Then this just sort of shows what what we're doing there. So then I can see them all together. Okay, decision points. How does this help me make design decisions? And I would say there's sort of 3 different ways that I sort of start to think about this. And first of all, I need to have the correct geometry, and that's what I use Solidworks for. And then I need to understand how my device operates or functions. And that's what I'm using XMotion for, is to study the dynamic forces of it. Okay, and then the third is the structural. Okay, how does this function as I'm applying the stresses to it? And all three of those are important for me to develop a well-designed product. So when I go through this process, how it helps me is I feel like I'm able to get a really robust understanding of my design, how it's functioning under the conditions that it's being applied to. And to me, that's really helpful and powerful in a way that I wasn't able to do without these tools. And then a key point is just knowing what the worst case is. And as I think back to my hand calculations from my original process, I really didn't know how to evaluate the worst possible case scenario for this design. And by using these tools, I feel like I'm a lot closer, if not 100% nailed it, on what is the worst case scenario and what are the stresses at that point. So I'm really able to sort of understand it based on time as well, which is a key point. So, and ultimately, just driving to, like, this information has to help me make design decisions. Okay, well, so how did Seneca as a company, how did we become successful using modeling and simulation? And since it's a small room, I'll admit I nearly failed my FEA class in college. And yeah, it was my spring semester, my senior year, and I had a lot of other things on my mind. But it was close. And I'm so thankful that the professor probably, just had a little compassion and gave me a little bit of a curve there. But how did I go from, nearly failing, that academic class to really using it regularly, using the simulation tools, and being successful at integrating them, it being a valuable part of my design process? And I think it really came down to sort of three different areas that that I want to talk about. And I think these three areas really just contributed to the successful implementation for this process at Seneca. And the first one is the evolution of the simulation tools. The second is seeing it as an engineering business solution. And the third would be the collaboration. So the first point is the evolution of the simulation tools. And there's just been some really incredible transformation in how integrated the tools are right into the design environment. And I'm a designer. That's what I do. That's my passion. And I'm using this simulation as a way to help me. It's a tool in my toolbox as a designer. So by integrating these tools into the same environment, there's great gains to be had. And that was something that I really didn't see when I was taking the academic class, a little more than 20 years ago, is they were still, very separate tools. So I think that, just embracing and using those tools right in that environment is a very powerful way, and just embracing those tools. So the second thing is scalable packages. And if you look over there, I have it's a structural designer and then a structural engineer. And those are two different roles on the 3D Experience platform. And the structural designer is sort of their base simulation role. And what it does is it does a really good job at sort of stripping out some of the complicated, more advanced tools, and really focuses on on just the tools that you would need as a designer to do all of the sort of base simulations. And then if you want more advanced tools, then you would move to the structural engineer. And that was just a very real example for me because that's the process that I used. You know, I started with a base role and then I moved to the more advanced role. But it's an example of how the tools, they scale. And there's a broad range of tools, whether it's on the 3D Experience platform, whether it's with SolidWorks simulation. There's, you know, whatever your needs are, you can get a package that fits you, that fits your needs, that fits your requirements. So as these tools change, you don't have to be forced into a one-size-fits-all package. You can find something that it's going to fit and it's going to work for you. So adaptive tools for a broad range of needs. You know, that's sort of what I was trying to explain. You can see there I've got the assistant panel there. And then it's pretty small there, but you can see there's a help panel in the one picture down there too. So there's all these tools that are available for anyone who's just getting started, all the way up to if you're needing the advanced tools, you can find something that's going to fit for everybody in between. So the next point that really helped make ModSim successful at Seneca was just changing the way that I was thinking about it and seeing ModSim as a business solution. So as an engineer, I like to think that, when I talk about simulation, it's me, going into the back room and, crunching through the numbers and you get a pretty plot, and at the end of the day, you have the solution. But what I came to see is that I really need to see it as, have a higher view of it. And it wasn't just buying the software and running the simulations. To me, that's the fun part, that's the challenge. But I had to see it as something that had to fit in the business. And the business had to have some a benefit from it as well. And whenever you have change, there's risk associated with it. So I had to see this sort of from the company's perspective and understand that, the company has risk for me doing these simulations. It costs time, it costs money, I could be wrong. And so how was I going to manage that risk of change? And that was sort of a key aspect of successfully integrating it, was figuring out how to deal with that risk and do it in such a way that the company would embrace it. And the way that I did it was actually pretty simple. The first was education. There is so many tools out there to learn and to become familiar with it. The one I show here is the 3D Experience EDU website. Why I like that is because it was very methodical in the approach that it took. It built upon the concepts, and by the end, you had everything that you needed, and it was tailored to each role. Now, YouTube's great as well. You go on there, if you search SolidWorks simulation, you'll probably get 2.4 billion results. That can be good, but that can be bad. And I think the bad part about that is it's like, oh my goodness, it's like, where do you even start? So that can be, sort of a double-edged sword there. Practice. A big part of managing the risk is by being able to produce results quickly. And what I discovered is the more that I used it, the faster I could get at it. And I was able to produce those results quicker. And that, in and of itself, manages that risk to the company. So now it's not like I'm missing my deadlines, putting everyone behind just because I, want to run one more simulation. And the third point is the collaboration with experts. Now, I talk a little bit more about collaboration in the next slide, so I don't want to say it too much, but it's a way of managing that risk, is getting people involved that can help you, that know more than you. And that's, I think, a key point too, is finding those people that you can bring in that you are going to help you be successful. The whole team integration planning. So here, what I realized, at first I was like, oh, so simulation is great. You don't have to do, any prototypes, this and that. It's like, well, at first it took me longer. So it's like, all right, what's wrong with this picture? And, but what I realized is I had to bring the whole team in and use the sort of a left shifting approach, is a term that I've heard used before, is, okay, this might actually, I need to allocate time for the simulation. If all I ever did was design, do drawings, send it to the shop, I now have to change my schedule and account for that extra time for those simulations. And the next point there is really just cherry picking the right projects. And that there's always a tendency, and I made this mistake too, is to start out and you want to solve your biggest, hardest problem. And I did this, is very, very common to want to do this, but what I realized is some projects were much easier to use simulation on to solve than others. And really selecting those projects that I was going to be successful on, and sort of avoiding the ones that I didn't think I could be successful on. And ultimately, I still don't simulate on every project, so just being sort of looking at it just a little bit higher level and picking those projects. So the third point is collaboration. So it's kind of a catchphrase that everybody talks about now, but it's really a powerful tool, and it's so simple now to be able to connect with experts and specialists. And so here we got our resellers. I got my guy back there. I can see he's here. Steven, he's with CAD Dimensions, and he's my support guy, and just has done a tremendous job of helping me be successful. I can contact him. He has answers for me, very accessible. But there's all different ways to connect to different people, whether it's your reseller, whether it's with online communities, just so many different ways to connect with people. I show this, the swim, we have different communities. That's how I connect with people. There's so many different ways to connect with people, and everybody has their different preferences or different systems set up. And really, it's been really cool to be part of a global community as well. And that, is just something that I think about, 20 years ago when I was in college, it was just it was so hard actually to connect with people and in a global way. But now, so many of those barriers are gone, and there's so many different tools. And to leverage those, that has been a big part of my success with integrating the simulation into our design process, is being able to connect with all those different people. And the third point there is looking at a task-based instead of a siloed projects. Now, this might not be the first thing that you'd think about, but in a way, it's really helped us be more productive in our simulations, because we're able to have multiple users working on the same project and more specialized. So instead of one person just being totally dedicated, I can have one person working on drawings, I can have one person working on design, I can have one person working on simulation, all on one project. And we do that. We have done that at times. But it helps free up the people who are capable and able and excited and passionate about simulation to work on that. Instead of that having them forced to, to be doing something else, we're able to focus our engineering talent on the different things, the different specialty areas. And doing this all in the same data set too. So all that collaboration. So, well, was it worth it for Seneca? I mean, at the end of the day, was it worth it? And I have the equation there for work as a change in kinetic energy. And whenever an organization has a certain momentum, a certain energy, it's going to take work to change that direction. And as I think back, there is work involved in integrating this. I have my one slide at the beginning where I sort of show the journey that Seneca has been on. Has it been work? Yeah, it's been work to change the way that we do things, to learn the new software tools, to work with different people in manufacturing and bring them on board as well. So yeah, it has been work, but originally I was like working through this chart. I was going to have this chart that showed like how many dollars we saved and hours and this and that. And a wise person once told me one time that if you have to do a statistical analysis on it, it may not have made that big of a difference. So I kind of used that farmer wisdom there, and I thought about it differently. I said, well, what projects have I used it with that have made a difference? And these are just 4 examples, and they sort of cover different areas of our company that I've used simulation on. And they have made a difference. They have changed the direction of our design process and really made a difference in the products and the profitability of the company. So just thinking about it that way, I'm like, yeah. When I look at those projects, and I've got more. Those are just the cool animations I could show on the screen. I'm like, yeah, it really did make a difference. So that's it. That's my conclusion. So just sort of summarize, ModSim benefits. I can understand the problem. I can rigorously evaluate my design. And I was able to improve my design process. So as I use that process over and over again, the goal and the hope is that I get better products. So special thanks to everybody in the Seneca team. I'm not the only one doing all this stuff, working on it. And CAD Dimensions, I got Steven back there. So he's been a great help, support. And Amy Peterson did fixed up my cow. So everybody always said my cow looked a little plain. So I got my cow in my animations as she dressed that up for me. So, all right. Thank you everybody for listening. If anybody has any questions, I could answer questions for a few minutes.